I'm going to sit here and yell for the next hour. So thank you for kind of sharing a little bit of information about what your interest is. I'm kind of going to freestyle a little bit. I had a presentation, but since that's not really the case, I'll kind of go through and just talk a little bit about it. I can go through some of my slides. I can share my slides with you folks after. And as you're going forward from today, maybe we could do a little bit more hands-on at the check-in on next week. Pretty chaotic in here right now. So let's talk a little bit about kind of what is Git. So Git, by definition, if you Google the definition, it's a person, especially a man, who is stupid or unpleasant. So that's how we're starting off today. So in our programming lives, actually be coined after a British slang term like that. So Git was actually created by a somewhat unknown but warm-hearted software developer by the name of Linus Torvalds. You may or may not have heard of him. Has anybody heard of him? Yes, he's the creator of Linux, so he's kind of contributed a little bit to the world that we live in. So, and he had this to say about himself and naming the project, is that I'm an egotistical bastard and I name all my projects after myself. First Linux, now Git. So, hence Git. So that's a little bit of history lesson for kind of why this thing came to be named what it is. And we have some more fun facts. Is that kind of his thinking about how he named it was that basically nothing else was named that. It was a random 3 letters that didn't conflict with any other Linux packages. It's stupid, contemptible, and despicable, but yet simple. And take your pick from that dictionary of slang. When it's working good, it's the global information tracker, which is kind of what we use it for. And when it's not working well, you can read that for yourself. So, so if any of you aren't familiar with Linus Torvalds, he's very smart. He's contributed an enormous amount to the world we live in. He's also a huge jerk, but you know, we'll take it for what it's worth. But what is Git really, right? So that's kind of what we're here for. Git is a tool for it's called a DVCS, or a distributed version control system. And what is a distributed version control system is that basically in teams of software developers, you know, I may be working here. Somebody, you know, Ray may be working right next to me, or Ray may be in, you know, San Francisco, or I may be working with teams in India or all over the world. So we need a way as software developers to kind of come together and collaborate and share our code and work on projects together. And kind of, you know, how we did that prior to version control systems that weren't distributed. You had to be connected to the internet, so it's kind of a faulty process, or somewhat of a painful process. There's other kind of technical limitations as well. Another way, you know, people that aren't familiar with these systems are, you know, sharing files, you know, zipping something up and sharing you a zip file, and you have no idea how to merge what you did with their changes, and it's just a very chaotic and very faulty process because us. So we use Git. So Git specifically was a better solution to some of its predecessors that I won't go into all of the details of what the other flaws were, but very simply, Git was a solution to allow developers to work in a distributed manner with a full copy of the entire repository, or all the code, all the files, regardless of whether they were connected to the internet, and be able to work and make changes and commit those changes, and then at some point sync them with other software developers as well. And it was built around the concept that branches are cheap and easy, and we'll get into a little bit more into what are branches, but there's a lot more technical kind of, you know, challenges solved, but these are really the main two, I think, that really separate Git from other tools and the main reason why we use them and why it was created. Any questions about any of that? No? Make sense? Okay. So kind of what we now have is, you hear a lot about GitHub, right? You saw it on my slides. I think some of you said you've heard about it before. So what is GitHub? GitHub is simply, it's a public website and a social network exposing Git remote servers to the masses. And so the way Git works is that basically I have a version of the repository on my machine, and there's one on the server, and those two things talk to one another. So I actually have a kind of a diagram of that. So this is kind of how what it actually looks like, is that we have remote servers on the internet, and then we have users that are working on copies of that code base on their local machines, right? So GitHub did not create the concept of this server and kind of client model, but what they did was they really popularized it. Is that they built a way for people to come together. I mean, everyone here is familiar with the concept of a social network, right? We have friends, we have followers, we watch certain things, we track activity, we communicate with people, we establish relationships. So GitHub did that around code, and really in the spirit of open source, of sharing code and learning from one another. So GitHub I think it's one of the most prolific sites on the internet, one of the most valuable sites on the internet, in the fact that it hosts some of the world's most widely used software, code bases. You can see the code. It's open source. You can see how things work. You have access to the people that built that software. So I can go on GitHub and learn from people that I would never have access to in my day-to-day work life. I can see how they build software. I can see how the software evolves, how what their process is. I can meet other people that way. So it kind of, from a professional sense, allows me to establish kind of new relationships and stuff like that. All of my friends, we follow each other. I see the stuff that they follow or they star or they copy, fork off, and I check it out and I learn new stuff that way, and we get talking about it, and we all kind of grow as a community that way. And I think that one thing makes it such a powerful and enabling tool for implementing solutions, for education, connections, all that kind of stuff. So like I said, I love GitHub. I think it's probably I think it's the best site on the internet. Yeah.
If I had more thumbs.
See? All thumbs up. So just to summarize, GitHub, it's a great way to learn. It's a great way to contribute, to share, and to grow. And you can actually go contribute to projects that you don't even know the people. And kind of in the spirit of this event of collaborating to solve problems, that it also serves as a means for that as well. So, can everybody in the back, can you guys hear me? Yeah? All right. Okay. I'll yell as loud as I can. You're welcome to come forward a little bit if you want. So this is kind of the part of my presentation where I was going to walk everybody through on laptops, but most people don't have laptops. So for those of you that do, I'm happy to schedule another session and go through this, but I'm going to kind of adapt a little bit to serve kind of everybody that's here. So I think I'm just going to walk through GitHub a little bit and show you more the value of GitHub. I'll kind of go through my slides a little bit. So everybody that's interested, after this presentation, go home, create an account, sign up, and that's kind of the first step. Very easy to do. This kind of doesn't apply to the broader audience, but we have to log in and authenticate. And when we're pushing code up to remote servers, we have to, authenticate who we are, just like any other site. So this was kind of us. I was going to walk people through how to do that. Yeah, so that's all kind of authentication so far about GitHub. I'm going to pull up the site and kind of just walk through some of the features and kind of show a little bit what it's about. But any questions in general before we do that? No? Okay. Cool. So let's check out GitHub. Okay. So what we see here is that I have my GitHub account. I have my personal account. I also am a part of many other organizations. And as you can see here, I actually contribute to many organizations and part of those organizations. And so I kind of have my, just like Facebook or Twitter or something, I have my feed of what people, people that I'm following. So I have my friends, they're kind of like, actually these are my employees. They're working on stuff, they're pushing it up. I see what they're doing, I see their activity. If I want to check it out, I can kind of go see what code they pushed up. I also have, I follow my friends, and my friend, this is Ka'a, I think? Yeah? And so he started a repo today of what is Babel-I, and I'm like, oh, what is that? I've never heard of that. Let me check it out. And now I kind of go look at this, and I'm like, oh, cool, I do ES6, like, I do Babel. I should probably know something a little bit about this. Like, I hadn't heard about this before, but I can get in here, and I can kind of scroll down. I can read about what it's for. So I see it's a minifier tool. It tells me a lot about the repository itself, like what is this code for, how to use it, how to install it, things like that. So good repos give you a lot of information on this home page. And so that's kind of cool, so I'm like, oh, that's cool, I like that. So I'm going to do what Ka'a did, and I'm also going to star it, and anybody who's following me potentially now sees this in their feed, and it's this is way better information to be crossing your field of vision every day than half the crap you see on Facebook or Twitter. So, I encourage people to, start following people and see kind of what you stumble across. Much more valuable, in my opinion. So that's cool. I kind of discovered something new today. Ruby? My username is Jaywon, Jaywon. So I'm up here, Jaywon. If anybody wants to follow me, I star way more stuff than I can actually follow, but it's cool. You guys can see it, see what we're into. For those of you that want to use this kind of professionally, or maybe for I don't know, for school probably may not make sense, but you can have private and public repositories. So you can't really see here, but on the right I actually have some that are slightly yellow. Those are my private repositories that you guys cannot see unless I kind of added you to them. And then we have the public stuff like the Babel one I just looked at, where anybody could see it. It's totally open and open to the public. So you can create kind of professional accounts and personal accounts to kind of do things you want to share and things you want to keep private. It does accommodate both those scenarios. So yeah, actually here's a good one. This has HACC challenge information. So this is actually probably a good one to follow. This has all the information from the event team that they pushed up. Yeah, so what else do we have here? So yeah, so that's kind of how we can find new stuff. GitHub has a concept called forking. So let's say I want to copy this. I actually want to kind of take this and make it my own so that I can kind of take it in a new direction and do a lot of work to it. I can actually fork this repository. And if I click this fork, I can actually choose to basically take an entire copy of this repository and make it my own. And so now we see here, over here, is that I actually own this repository now. Like, I can make changes to it, I can do whatever I want to it. And this is what open source is all about, is that you did something that I saw value in, but maybe I want to do something else to it, and that's okay with you, and it gives me the ability to kind of run with it. So so this happens all the time, is that people, you know, take existing code and they kind of pivot it and do something new with it. So I can do whatever I want to this now, and other people can fork it for me and what have you. So any questions so far about any of that? No? Okay. Cool. Let's see. Let's go to a repository. So Ruby and I were talking a little bit about this beforehand, is that when we're working as teams, a lot of times we have to communicate like, oh, you need to do something and you need to do something, and we have to kind of keep that information visible and consistent. Like, emails are a terrible way to do that. Text messages are a terrible way to do that. You know, any kind of verbal communication gets lost in time. So what we have is we can actually track issues to any of these repositories. So I can actually say, I'm going to create a new issue to make install instructions, right? And I need a working README of how to install and run project. So I can actually go kind of like submit this new issue. I can assign it to somebody. So if I have other people on my team, I could assign to, let's see, I'll assign to Ray. And you know what? I'll put oh yeah, Ray's good. So now Ray actually gets a notification on his account and in his email that he got assigned a ticket, and he's going to go look at it, and we can actually have kind of running dialogue on this ticket. Is that if I have any other thoughts, I'm like you know, like, oh, I forgot to tell you how wonderful you are. I love you, Ray. So, and if he has any questions, like, dude, I don't know what you're asking me. That's cool. You care about me, but what am I supposed to do? We can kind of have this visible thread. We can pull other people. I can pull Sean onto it. You know, maybe he has some knowledge that would help us solve this problem. So if you go look at, like, you know, very popular repositories, you'll see hundreds of issues. You can, as for any of you guys that are students, this is one of the best ways to kind of get yourself kind of some attention, start working with actual professionals. It's a great thing to put on your resume, is that you can go find bugs on any repository out there. Go fix a small bug. People appreciate it. You can, you know, as you're getting out in your professional lives, you can go out and when you're interviewing, say, I contribute to this open source project. And me as an employer, somebody comes to me and they tell me that they contributed to, you know, Babel. And I'm like, what? I'm like, I use Babel all the time and it drives me nuts. I'd love to have somebody that knows more about it. And just it sets you apart as a professional, of somebody that's going above and beyond and isn't just kind of learning, but is actually engaging in community. So I highly, highly encourage any students to go find a project to contribute to. Like, it sounds intimidating. The hardest part is just starting, always. Even for you, you know, like, you know, I don't know how old you are, but you look young. It's a way to get access to other programmers who are like, wow, this young gentleman is contributing to our repo. We should like, I'll give him some guidance and some mentorship. So it's a great thing. And again, all of what kind of GitHub offers you. So Sean, Ray just went and kind of added something. You know, he said he might need help from Sean. Sean's now pulled into the conversation, and now we have the ability to have a consistent line of communication. So we use this for professionally. It's not just kind of the open source world and everybody else's code as well. So any questions about that? Okay, kind of jamming through here. So we got I'm supposed to go to 2, so we got like 25 minutes, so I'm just going to keep going. I'll kind of go back to my presentation. I'll see kind of what I had there. So I'll post the slides in the Slack channel so everybody can see these afterwards. But if you want to go home, you want to install Git, you have to have Git to use GitHub. Git and GitHub are they're not synonymous. So it's always important to point that out, is that Git is just a tool. You could use Git for years without ever even having a GitHub account. It's just that GitHub is that public social network built on top of Git, the technology. So, but you do have to have Git to use GitHub. So no, if you already have Git installed, you're good. So Git is installed on your computer. So, whoops, oh shoot, I just killed my presentation. Okay. Yeah. Yeah, so when I talk about Git is it's a command line utility that I have on my computer. So, I can jump to So I have a bunch of repos here. I could go into any of these, and I have Git here. I can run Git commands. I don't ever have to be signed up for GitHub to use Git. So Git is just a utility. If you want to learn more about it, you can see all the commands. If we have a little bit of time towards the end, I'll do a little bit more. This is kind of the presentation I was going to do, but like I said, without everybody having laptops, kind of just didn't want to, or it didn't make sense. So if you go home, install Git. There's instructions here. Configure it. When we're working with, well, let me see here. Is there anything else on GitHub I should talk about? I showed how to fork. Yeah. What's that? Well, that's what I was gonna do. I was gonna go through the whole thing, but nobody has laptops, so I'll just talk about it. Can. I was gonna kind of just keep it more informational, but yeah. So basically, if we go back to this diagram, kind of what you have here is that, again, you have this remote server, and you have John over here doing his work. You have Kelly over there doing her work, and so the remote server is always kind of the main point of where that code lives. We're just pulling down copies into our own workstations to kind of work off of, and so there's some general basic commands that allows us to kind of sync these things up. Is that when we pull down a new version of a repo off of GitHub, we're actually cloning that repo. So I can kind of show you what that looks like. So if I actually go here to my repository page, I can grab this link to clone, and if I go over here to my command line, so I could do Git Clone here. And what this is doing is this is pulling that code off of GitHub down into my local account. And this is going to be really slow because we're on a, I think I'm getting throttled already because I was on the connection all morning. So, but basically what that's going to do is that's going to take all of this code, in here, all of this is, every single one of these folders has a bunch of code files in it. So this is JavaScript. Everything's running really slow, but basically all of these files are now going to be on my computer once I finish that step. So, so that's kind of the way. So Git Clone, that's the way to get code from GitHub onto my local machine. Okay. We have the ability to also create repositories from scratch on my local machine without pulling it down from the cloud. And so we use a method called git init for that. Again, that was kind of part of my demo, which I won't go through. And then we have git pull and git push, which are pretty two crucial commands for using Git and GitHub. Is that when I make changes, I have to push it up so that other people can get those changes. That's called Git Push. And then we also have Git Pull that pulls down changes that other people did to my repository. Oh, okay, cool, thank you. Any questions about kind of syncing repos? I'm going through this very quickly because this is very different than how I planned it, but any questions? No? Okay. So basically, so that actually finished. So let's say I want to actually make some changes, right? So, so let me go change a file. Well, actually, okay. So, okay. So basically, so what I'm going to do, so say I'm actually working on this project now. I pulled it down from GitHub. I actually have a copy of this remote code repository, and I'm going to make some changes. And so what I'm going to do here is I'm going to add, I don't know, a new function that does things. And so this is a very powerful function that made my application very, very, very powerful. So, so now what I can do is I can see kind of, if I do a Git status now, so this is kind of more of like the workflow of me using this day to day, is that I made a change. It tells me that my branch is not up to date, that I have local changes, and that's what that kind of yellow text signifies, is that it's letting me know that what I pulled down is different than what I have now, which obviously is what I'm doing. That's the whole intent, right? I'm working on this project. So if I actually want to push this back up to the cloud, I can add this file. So I will add this to, and if I do a git status again, what we see now is it still shows that file changed, but it went from yellow to green, right? And so that's showing me that I've kind of, it's what we've staged it, which I've told Git that when I can do a commit, I want this file to like officially be saved, because we can actually bail out of here at any time. Like I don't have to save these changes, even though I want to save this. I'm going to push it up in the next time I do a commit. And so I could do that right now, is I could say git commit m. I'm pushing this up on master. Yeah, it's okay. So added new function. So what I'm doing is I'm creating a message, is that this is a point in time, is that now that I've added this message, is that I can now, if I do a git log, so I can see kind of my history, it shows me that on Saturday, August 27th, I made a change and I left that message saying that I added a new function. And you can see all the other changes that we'd had prior to that as well. So now I'm good. I've added my change. I've committed it. Now I want it to go up on the remote repository. And here's when I would do a Git push. So now if I do a push, it's actually going to take those changes and save it up on GitHub. And if I actually go to GitHub, I can actually see that if I refresh this, is that my latest change was last committed a minute ago. So now Sean or Ray could pull down, they would do a git pull and they would have my latest change. And so I never had to like send them a zip file. I never had to like call them up and tell them like, oh, hey, add this function. We just have a nice kind of workflow going. So that's kind of the very basic workflow of using Git and working with teams. And some of the basic commands. I was gonna do some walkthroughs. Feel free to do these on your own, or like say we can do another session. I'm happy to schedule that. The other part of kind of working in teams is that a lot of the other, the reason we use Git and GitHub most of the time is because we're working with other people. And so that's why we use version control, because without it, working with other people is just, like I said, it's painful, it's faulty, and it just does not work. We also don't want to always be working on what's called the same branch. And so what we have here is that if I ask what my branches are, I have one branch on this repo, and that's master. So that's what that's showing me here. And so when we're working on repositories, we actually have the ability to break off of that main line of development and kind of work on our own. So I don't want people committing to master without us having talked about it. And so when Sean comes in, he's going to create a feature branch, and he's going to do his work on his own that's not going to conflict with anything I'm doing until at some point in the future we decide to converge or merge those changes. So basically, Sean's going to kind of be working, or we're going to have our master branch here. Sean is going to branch off, or actually, yeah. So he's going to have his feature branch. I'm going to branch off this way. And we're going to keep kind of working. So what we've done here is that I'm working on we both split off from the same starting point and the same copy. I'm committing my changes regardless of what he's doing, and he's doing the same thing. And at some point, I'm going to merge these changes back into this main line of development. And now master now has my changes. And what Sean can do is he can then go pull in my changes into his branch like this. Sean now has his changes, he has my changes, and he could actually then push his changes back into kind of our main line of development. So that's kind of a crazy picture if you haven't really worked with Git. But again, just in the sake of time, that's kind of the workflow of how we work independently and come together at some point in the future, because that's ultimately what we're doing, is we're working on separate features of a single code base to get to an end point of having working software, right? Let's see. So this kind of demonstrates a little bit more kind of what I drew up there. Any questions about that? We got about 10 minutes.
How do you know, like, if it's going to, you just commit the code, then you test it, and then you see if it works? Or how do you know it's all going to, like, come together, I guess?
Okay. So Ruby's question was, like, when we're working separately like this, how do we know that when we come together that things are going to work? And that's a very good question. With all of these tools, and I do have this on a slide somewhere, is that all of these tools do not mean that you don't communicate with other people. And so that's always my kind of reinforcement, is that just because we have tools that take the faulty human process out of this doesn't mean we can take the faulty humans out of it. And so we still have to communicate, we still have to talk to one another. The tools will tell us if something's wrong. So if at some point we try to merge and, like, we both change the same file, Git's going to say, I don't know what to do here, you guys got to figure this out. And that's when me and Sean would have to come together and say, hey, this is my changes that I did, these are the changes that you did. But if we're working on separate parts of the application, those points in time actually come together fairly seamlessly. And the way we would know that the software is still working is really outside of Git, and that's writing tests, right? So that's a whole other kind of world of software development, is that and a justification of why you write tests is because when you have all these people touching different parts of the application, how do you know that it's still working? Is that you have tests. And when Sean merges his stuff into my branch and our tests still pass, and we have confidence in our tests, then we're like, cool, like what you did is good. I think we're going to run out of time, but another part of GitHub is you can actually do code reviews and submit what they call pull requests to other people. And so he can, before he actually commits, he can submit a pull request. I can actually look at the code and be like, no, there's something wrong with this, or yeah, it looks great, let's merge it. And again, I was going to kind of do that hands-on, but yeah. And that should happen all the time. I mean, like I said, the tools don't take the requirement that we have as responsible software developers to still validate each other, and not just finding errors in each other's work, but communicating that we're learning from each other, that he does something that I wouldn't even thought of doing, I benefit from it, he benefits from it. If we catch bugs, that's bugs that don't get to our users, and potentially impact our business, all that kind of stuff. So, did everybody kind of hear the question and kind of what the answer was? Yeah. So it's a very difficult environment for a presentation, but so yeah. This is one kind of what I diagrammed as one workflow. There's other workflows of how to work in teams with Git. I don't think we're going to have time to demo it like I wanted to, but check it out if you're going to start working. Is that Git Flow is a very good workflow for working in Git. GitHub supports that workflow very well when you're doing pull requests and stuff like that. This image that I had up here, this is a Git Flow model, is that we never touch master. Master is like our shrine. Like, master should never be broken, it should never be dirty, it should like always have working, functional, tested code. So what we do is when we work on development, we actually branch off of master to create this development line or branch, I should say. We all branch off of that to make our feature branches, and then our feature branches go back to development, and then we validated that it passed all tests, that it's passed any like QA, any of that stuff, and it's ready to go to a production environment. Merge conflicts will happen. again, kind of we talked about it a little bit, but like I said, don't freak out when it happens. The tools are very helpful to kind of work through it. And there's a couple rules of handling merge conflicts. Merge rule number 1 is great tools don't replace the need to communicate with your team. And when conflicts happen, find out why they happened. Figure out, my code says this, your code says that, which is right? Are they both right? How do we fix this? And then the second rule of merge conflicts is see merge rule number 1. So, Fight Club style. We're almost out of time, so I think the last thing I want to talk about is git ignore. In a lot of programming languages we use, there's a lot of garbage that we don't want in our repositories. Like if we're doing like .NET, there's all kinds of generated files that they generate the same way on your computer as they do on mine when we compile. We don't need those in the repo. For us that do like open source like Node development, we don't want Node modules, so there's a lot of things that we want to ignore. We only want the code really that we write to go into our repositories. And that it's really subjective to the language what those things are. But there's a nice list of git ignore files on GitHub that comes standard for if you're doing Java, if you're doing JavaScript, Python, C#, what have you. And I think the last thing I wanted to say, security. GitHub is a public site. People can see your repositories if they're public. When you're working in applications, a lot of times we have passwords or we have API keys that our applications are needed to work. So GitHub security rule number 1, don't ever commit secure file information in your code to GitHub. The rest of the world will see it. You can actually Google or search in GitHub password and see a bunch of people that broke that rule. I forget there's other people have looked for certain things, and there's a lot of people that have broken this rule and are I don't think I need to say too much more about that.
Is that when you embed your password in the software?
Yes. Yes. We need it in our working software because that's just how it works, but it should never be committed to our code base for other people to see. So there's lots of workflows around how to manage those credentials, but they should never, ever go into your repository. Anybody know rule number 2 of GitHub security? Yeah. You know what I'm saying. So yeah. I think that's about as much time as we have. So I can take any last questions. Yeah.
If you want your students to start getting involved in open source projects, is there any good projects to start with? I know it's but are there better places to start than others?
In terms of finding projects for your students to contribute to? My recommendation is always that it should be something that they're interested in, because otherwise they're just not going to do it. If I tell you this is a great project but you don't care about it, you're not going to go work on it. So I would, if I was doing it, I would try to have them make that an exercise of go find something you care about, find a project, and even if you contribute documentation, I would love if people came through and contributed documentation to every single one of my projects, because I don't have a lot of simple bug, there's many ways to go about it, but I think the best way to get people engaged always is based on interest. And so if you can get them interested, then that's kind of the best way to do it. Yeah.
Would it be better to start working with a newer project rather than an older project?
In what sense? For yourself to learn? I would kind of walk through my slides, or you're welcome to come to another session if we'll do it outside of here. Start with a clean slate, something that doesn't matter, and just learn the utilities. work with, I mean, any file you create, whether it has real stuff in it or not, it's file based. So you could put garbage in the file and just work with the commands. And then once you're comfortable with the commands, then then you can use it on a real project. It's hard to say. I don't know kind of what you're thinking, but it's fairly subjective based on kind of what the application is. So. Yeah.
The slides.
Yeah.
So they're going to be available?
Yes, I will post them in the HACC Slack channel, and then I'll send out some times that if anybody wants to come and do like the hands-on version that I was going to do, I'm happy to run that when we can effectively do it. So yeah, I didn't know it was going to be so chaotic in here. So what? Yes. Yep. Yeah, we'll be at the check-ins too every week that we're doing the check-ins. We're there to support whatever you guys like. We're just open format technical support. If you need Git support, GitHub, code questions, how to build things, whatever. Like it's pretty open format. So cool. All right, thank you everybody.